Can everybody hear me? All right, that's cool. All right, guys, thank you so much for having me here. All right, while I get the clicker, I can tell you guys a bit about myself. So I'm Sarjeel Yusuf. People call me Yusuf because it's easier to say. All right. I was originally an engineer until recently, where I switched my role to product manager. Um, I work at Atlassian Opsgenie. Oops. So I guess everything's just breaking down now. Okay, here we go. Yeah, I work at Atlassian Opsgenie. So everybody's heard about Jira, right? So that's one of the more popular tools of Atlassian. What do we do at Opsgenie? Basically, Opsgenie is an incident management tool. So all your alert consolidation, alert routing, pinging on-call personnel, right? So that's what we do at Opsgenie. And we're based in Ankara, Turkey, so I flew down from there. I'm actually Indian, and it's been around 5 years since I came back, so great to be back, right? And thank you for having me, guys. I've spoken at various serverless days and DevOps days. This is the first time I'm speaking at a GraphQL conference, so let's see how it goes, right? So what are we speaking about? Well, one of the main motivations of this talk is something that I read a while back by Matt Warner, who's the publications manager at Devada. And he said that the Internet of Things is an industry that has not exploded the way many thought it would, right? And he wrote this in the D-Zone 2019 guide to Internet of Things. This is the opening statement to the Internet of Things guide of 2019 by D-Zone, right? And basically, oops. Basically, my specialty or my interests lie in cloud computing, serverless, and DevOps, right? And I'm always trying to find new use cases where we can apply serverless and serverless functions or anything related to DevOps. And what I realized was that IoT is such a field, is such a domain that can benefit heavily from both GraphQL and serverless, not serverless alone. By combining serverless and GraphQL, we can accelerate IoT adoption a lot. So just before we start, like, does everybody, just a show of hands, who knows what GraphQL is? Just a show of hands. I'm just hoping that everybody raised their hands. I mean, this is one of the last talks of this conference. If somebody didn't raise their hands, I would make fun of them. So this is important because I'm going to presume everybody already knows what GraphQL is, and I'm going to talk about how we can combine serverless with GraphQL. Building upon already known knowledge of how we can use GraphQL. So what's the agenda for today? We'll talk about the IoT conundrum. What's wrong with IoT? Why didn't IoT explode as an industry as was expected? We expected IoT to solve everything. And since we have all been in university and since the early 2000s, we've been hearing about how IoT is going to revolutionize the industry and the entire economies. But we don't see that. We don't see that. It's now 2020, and we still don't see that, right? So what is the IoT conundrum? What is the serverless solution to it? And what is the graph? How do we add GraphQL as a layer to enhance the solution? And why is GraphQL and serverless great for this combination? So many people, speakers before me have come up, and we all do acknowledge that using serverless with GraphQL isn't always the best choice. But what I want to show you guys is maybe for IoT, it is the perfect choice, right? So let's start. And as we start, we'll start with a story, right? And the story starts from my childhood when I was growing up in a small country in southern Africa, which is called Zambia, and we grew up next to this Luangwa National Park, and and this is where I believe IoT applications could be very useful at the South Luangwa National Park because there's poaching. You have all these beautiful animals. I grew up, just kilometers away from all these beautiful animals, such as giraffes, wildebeest, lions, and one of the most deadly animals, my younger sister. So, so I believe that we can use IoT to solve many problems that are plaguing the socio-economic domain of several countries, of several economically weaker countries, such as the country of Zambia and Zimbabwe. So, what is the IoT conundrum? Well, in the private sector, we see great leaps in the IoT sector. So according to the International Data Corporation, worldwide spending on IoT will reach $1.2 trillion. This is a 13.6% compound annual growth rate over the years 2017 to 2022. Right? Ericsson, the telecommunications giant, forecasts that IoT cellular connections to reach 3.5 billion in 2023. This is a compound annual growth rate of 30%, right? So we're seeing these amazing figures, but what's going wrong? Why don't we see it solving the problems that we always hear about in the news? Refugee crisis, on the borders of Turkey. How do we solve sanitation in India, for example? All of these problems can be solved. I'm a technophile, right? I believe technology can solve a lot of our problems, and that's what. And I believe that IoT is something that we can use. But now the only thing that IoT is being used for is telling me if I need bananas in my fridge or if I've run out of milk. Like, come on, man! Like, are you serious? Like, we made, a bunch of smart people got together just to tell me that I need to buy new milk. Come on, man! Like, we can do better. So what's the problem? And this chart, I think, explains the problem really well. So if we look at the statistics of cellular IoT connections, we mostly see that the largest adoption rates are within Northeast Asia, right? And you see a disparity over here. Like, Africa isn't even mentioned in this report. And that's because of the funding and the technical limitations that economically weaker nations have. Right? So, for example, these are the problems in the public sector, right? So, according to Marilyn Ndubuku and Dr. David from the Engineering Federal University of Technology in Nigeria, IoT solutions in Africa is far behind that of the EU and North America, right? This was published in their research paper that highlighted the benefits of IoT in solving various issues plaguing the African continent. The paper is The Internet of Things for Africa, Challenges and Opportunities. It was published in 2015. Unfortunately, Dr. David is no longer with us. He passed away very recently, right? On top of that, Andrea Zanella and her team published in their paper, Internet of Things for Smart Cities, that the lack of standardization, connectivity, and technical capabilities in economically weaker nations is one of the bigger problems of why IoT adoption is not as we see it is, right? So let's just think of the small country of Zambia again, and you have vast plains of jungle, right? Vast plains of jungle. There is barely any cellular connectivity. There's barely any cellular connectivity, and in these, can you imagine setting up IoT devices over there? It's nearly impossible, right? So what is the solution? Well, the first solution is a serverless solution. And maybe I'm a bit biased over here because of my love for serverless, but I really believe that serverless is a platform that we can use to solve most of these problems, right? And how do we get to it? Well, first of all, who is familiar with serverless? Is anybody using serverless? I see one guy, really excited over there. Just raise his hand. Anybody else who's familiar with serverless? Right, that's great. Not a lot of people. So let me give you a high-level view of what serverless can do. So there's actually a misconception about serverless. When people say serverless, people imagine Lambda functions and Azure functions and Google Cloud functions and whatnot. But that's not exactly what serverless is. Yes, that's the main domain of serverless. Yes, most serverless is more popular used over there. But serverless can be any service where you have the abstraction of complexity. So most of the complexity is supposed to be a managed service. So most of the complexity is abstracted away to your vendor, right? So for example, with AWS Lambda or Azure Functions, you don't need to set up your networking, your security as you would usually do in EC2 with EC2 containers or Kubernetes, right? So it's very easy to get up and running with serverless functions. It's potentially lower cost, and this is because of the pay-as-you-go model. So with the pay-as-you-go model, you actually only use those. You only get billed for those invocations or those instances of usage that you consume. Right? So, for example, with a container, for example, with an EC2 function, with an EC2 container, you would get billed per the hour. But with Lambda functions, with AWS Lambda, you get charged per invocation. So, and how does this benefit IoT devices? Well, IoT devices. Think of IoT in a way that, so we know that economically weaker nations do not have the financial capabilities to adopt, quality level IoT. Right? So where do they get their compute services from? If they get their compute services from on a serverless platform, the thing over here is that they can potentially lower costs, right? And this is something that was talked about by in the earlier talks, right? People go to serverless. People usually move to serverless for lower costs, right? And there's also the benefits of scalability. So again, since this is a fully managed service, you don't, people adopting IoT devices. So like, for example, if the South Luangwa National Park decides to have an IoT system, they don't need to think about servers anymore. They don't need to think about how many servers they'll need. They don't need to think about how many EC2 instances they need. They don't need to think about, buying EC2 instances on, under the spot pricing model, They don't need to think about that. They know that they just have a Lambda function that will scale according to their needs, right? And let's look into the benefits of this. So let's look at the reduction of cost. So serverless entails that you only pay for the resources that you use, right? Considering AWS Lambda, and like let's actually see how cheap it is. So here's a comparison of an EC2 function. So this is an M4 function, right? And if we compare it to a Lambda, right, we can see that it is around. You can actually to break even to the cost of paying for that EC2 instance for 1 hour, you would need around 16,000 invocations per hour, right? Just to break even with that M4 large instance if you allocate 128 MB. However, if you allocate more memory, then you come down to around 300 invocations. And imagine the use case over here. So if, let's say, you have an IoT device being used in the South Luangwa National Park for poaching, and you're recording all the animals, how many invocations do you expect to be used per hour, right? You could go up to 16,000. So maybe in 1 hour, you find the animals, you find the herd of wildebeest, and the wildebeest herd usually contains 2,000, 3,000 animals, 2,000, 3,000 individuals, and in that herd, you record everything. So let's say you even go up to 20,000, but that's 20,000 invocations for that hour. Afterwards, you probably won't see invocations for a couple more hours. So you're saving costs like that. And this graph shows how manifests this information, right? And then let's talk about the ease of building in serverless. So building IoT devices itself is very hard. Has anybody here worked in IoT before? Anybody? All right, there's a couple of hands, right? I hope after this talk, people get into IoT more and get into IoT the right way with serverless and GraphQL. So basically, the ease of building, IoT devices, building IoT devices. So you're thinking about hardware, you're thinking about, compute, you're thinking about, how all these things are going to communicate, how all these devices are communicating with each other. The networking itself and security itself are two major concerns over here, right? With serverless, at least you can abstract a lot of the responsibilities of your compute services and your intended, even if you, for example, if you use AWS Event Bridge. Has anybody here heard of AWS Event Bridge before? Just nod your heads. No nodding of heads. Okay, there's one guy. Okay, I'm going to talk to that guy after this, right? So with AWS Event Bridge, it's basically a serverless event bus, and it really abstracts all your communication needs in terms of how you send events from one target to another target, from one source to a target, right? So you can abstract away a lot of the complexity and primarily focus on your business logic over here, right? And yes, you may still have, so compared to containers, like when I graduated, I got up and running with serverless functions. I then started working with containers, with Kubernetes, with EC2 functions, and it was damn hard, man. It was damn hard. Like, there's a large learning curve for me to get over. And remember, coming back to these countries, coming back to the countries where we're trying to solve a lot of these socioeconomic problems with IoT devices, there is definitely a lack of talent, right? I mean, there are very few examples in the world where countries that are undergoing such problems have the best talent in the world. And even if they do have the best talent in the world, those countries experience a phenomena called brain drain. India was experiencing that problem a while back until India improved, and now we have, you have some of the best infrastructure and best startups in India itself. So India managed to get over the brain drain problem, but for example, Zambia still goes over, still is experiencing the brain drain problem. Right, so the brain drain problem is basically the best talents going to other, emigrating away for better opportunities, right? Um, so with, so as we can see that there is also some problems like such as fear of lack of observability and security aided by um, there's a fear of observability, and many people also have this misconception about serverless. And I say it's a misconception about serverless being not the best in terms of security, but there are third-party SAS tools that help you get by. So you see, as serverless grows as a solution, there's a whole ecosystem of third-party SAS tools that you can use to ease your development in serverless environments. For example, when it comes to monitoring, there are several tools out there, such as Tundra, that provide Lambda monitoring in AWS. And then there are tools such as Nuweba that provide security, right? So, and we'll talk about these problems in more detail as we go along. Scalability. So let's take another example of, apart from the South Luangwa National Park. If you take another example, like I'm pretty sure mostly everybody here knows what the IRCTC is, right? Who has ever tried to book a ticket on the IRCTC and just got frustrated? Like, what? Nothing works. Nothing works. Are you kidding me? And that's because, millions of people are trying to book at. I mean, apart from other problems, one of the problems is that millions of people are trying to access the network at the same time, and that's just, creating really bad performance, right? Imagine it just causes a lot of frustration. After a point, you're like, screw it. I'm just walking. I'm just walking to the next city. That's what I'm just going to do. I've been back after 5 years. My family came down to see me. They couldn't book a train ticket, so they just flew. So it's because of this problem. Imagine if you had auto scalability. If the servers could, if your node workers could go up and down depending on the amount of traffic that's coming in, then we would have had a much better experience, right? So that's a high-level view of how serverless benefits IoT adoption. If we talk about GraphQL as a data querying solution, so there have been really experienced speakers before me who have already talked about all, define what GraphQL is, how does it work, and everything. If we just go over it, how does it actually affect IoT devices? So, we already know that the syntax defines how data should be retrieved. We know that it's it's a client-driven solution, and we know that one of the major benefits is that it includes a single endpoint, right? So there's no we managed to get over the issue to some extent of overfetching and underfetching, right? And one of the major reasons for this is the application data graph that even Karthik just spoke about in the previous in his lightning talk, which is the previous talk, right? And so if you think of it, one of the major problems with IoT devices is that the lack of standardization, right? The lack of you have an IoT device, you have another IoT device, and all these IoT devices perform different things. And how do we? How does the so are you going to build endpoints for each of these IoT devices? How do these IoT devices know, which data is available and which data is not available? GraphQL solves that, right? And I'm pretty sure we all know how GraphQL can solve that, because GraphQL returns the data, provided that the entities and the nodes that the IoT device would like is present, right? So, for example, if you have one IoT device that requires the type animal with ID, name, string, and number, and reserve. And if you have another IoT device that requires, for example, diet, the diet entity, both of these IoT devices can connect to one endpoint and get the required information, provided that the GraphQL schema is built considering all of these needs, right? And for example, that's the query for one IoT device, and you can get the information accordingly, right? So, and there's also less network load. And the reason why there's less network load is because, as we already mentioned, single request, reduced round trips, you get all the data in one go, and also batch processing. So, batch processing is actually a huge benefit for IoT devices if you consider the problems of IoT devices. And the fact is that it's because let's say there's like lack of connectivity in the South Longo National Park. So there's also offline support that many clients give. For example, Abstraction gives offline support, and like it's built within. It's one of the features of that GraphQL and GraphQL clients have incorporated in their feature sets, which is offline support. So, for example, you can still go about processing data without connectivity. Once you reach connectivity, you can have a huge, you can push a huge batch and sync it with the data in the cloud, right? So why serverless and GraphQL? Well, because now with GraphQL, you're dealing with one HTTP endpoint. And you really want this HTTP endpoint to be reliable and scalable, right? You can have a lot of traffic at an instance, or you can have very minimal traffic at another instance. So that's why, and this is where serverless's auto scalability is leveraged, right? And that is where serverless comes into the mix. And for example, you can get architectures like this. So you have your IoT. So this, I'm more into one of my specialties, or one of my interests, let's say, is AWS cloud architectures. And so if we just, you can replicate this architecture in Azure or any other cloud vendor. So let's say you have AWS IoT, you have the gateway, Amazon gateway. You have a Lambda that has all your GraphQL logic in it, right? And then you have your data store such as DynamoDB and RDS, right? This can also be changed to something like this, where we've been talking a lot about GraphQL throughout these past 2 days, and AppSync, for example, is one of those clients that can be used to manage it, where you have Lambda resolvers. Now, Lambda resolvers isn't always the best option. You can, depending on your use case, you can go for other resolvers, but again, Lambda resolvers gives you that serverless capability and the auto scalable feature, right? Now, but there are some concerns with serverless. One of the main things is monitoring, as I already mentioned. Cold starts. Who's aware of cold starts? So the people who knew, yeah. Cold starts. So cold starts is one of the more dreadful problems of serverless applications. The timeouts, so most of the vendors have a restricted amount of time that your serverless function can run, because they need to reallocate worker nodes accordingly, right? And security, right? And if we start with cold starts, if we look at cold start, which is one of the more dreaded problems, now cold starts is such a huge problem that in all my experience, in my experience of talking to a lot of people about serverless, cold starts is one of those huge problems that keeps people away from serverless. And Mikhail Shilkov, who is a renowned luminary in cold starts in the serverless environment, actually ran this test, right? And we saw cold starts, especially for, as you can see, C# or .NET, highly in the second, right? I mean, maybe these are for JavaScript, for Java, these are still acceptable. But then, but in general, we see cold starts as a huge problem. And I actually looked into this problem. I looked into, how .NET serverless applications are actually affected by cold starts. And yes, we do have cold start problems, but we're also seeing improvements in, we're seeing cloud vendors trying to improve this. And the way they're improving it, so for example, we came out with, Azure and AWS came out with something called provision concurrency. So provision concurrency is a term that was used for AWS Lambda, where you already keep some worker nodes in reserve, so that whenever invocation comes in, that worker node is ready to take that invocation. So, I mean, how does the cold start, for those who do not know, who don't really understand the cold start problem, the cold start problem is because, so remember, serverless is a scalable service. So when you don't have any invocations, all those resources are torn down, so you don't get charged for those resources. If those resources are torn down and an invocation comes up, those resources need to start up again, right? And if invocations aren't coming frequently enough, those resources are torn down. If they are coming frequently enough, those resources are there for a certain amount of time, right? And we are seeing improvements in how vendors are dealing with the cold start problem. For example, the .NET Core runtimes. As we progress in the .NET Core runtimes, we are seeing huge reductions to the cold start. And if anybody wants to talk to me about this, I gave a talk about cold starts in .NET applications, and we can have a more detailed discussion about this later. right? What about security? Pardon me, what about timeouts? Well, with timeouts, again, we're also seeing improvements in cloud, with the cloud vendors and what is available. For example, both AWS and Azure increased the amount of timeouts available, right? So back in like the late 2017s to mid 2018, the maximum AWS Lambda function could run was 5 minutes. Who remembers that? Who remembers that the maximum AWS Lambda? Yeah. Now it's 15 minutes, right? Now it's 15 minutes. So we do see some improvement over there. Azure also has available runtimes for around 5 to 10 minutes, depending on the pricing plan. But that's still not enough. How do we get around the timeout problem? Well, the timeout problem is actually very simple to get around. It's basically how you build in serverless, right? And the way you build in serverless is that if you can think about async functions, you can really build over there. Coming back to GraphQL, this is one benefit that GraphQL really gives. Again, remember GraphQL, one single round trip, right? Reduce single processing, you get all the data that you need, right? So that means if your Lambda function is trying to retrieve data from a data store, with GraphQL you can do that quicker, right? And remember, we actually had a talk about this. One of the speakers, Soroduttu, if I'm pronouncing his name correctly, or I just call him Suro because so Suro from Oracle actually talked about this in his talk of performing GraphQL servers. So if you have a Lambda resolver, for example, how do you make that Lambda resolver? You need to think about how you make that Lambda resolver efficient enough so that you don't have those you don't have that timeout problem, right? When it comes to security, well, I believe security concerns in serverless is kind of a myth. You already have stringent vendor security, but that means vendor lock-in, right? The alternative to that is using third-party tools that I already mentioned, like Tundra and Nueba, to provide security and monitoring to ensure more secure serverless applications. Security is a major concern for IoT devices, by the way. Or you can have in-house solutions. So in-house solutions are viable thanks to open source projects such as Firecracker. So Amazon actually has an open source project called Firecracker, which is a virtualization tool, right? Um, and basically you can take Firecracker and you can build your serverless platform on top of that, right? Yes, that means more work for you, but hey, if it means more, if you're happy with your security and if you get the benefits of having a serverless platform and GraphQL for to boost your IoT adoption, then that's great, right? And usually I have this talk. I've given this talk before, and it's usually a 1 hour talk, and the rest of the half hour usually involves a demo. But since this is just a half hour talk, basically the demo shows how quickly you can actually set up a GraphQL serverless application using AppSync. This isn't only in AppSync, however. You can use other clients also, and the dgraph guys are actually doing their demo at the moment, and Karthik showed how you could set up a GraphQL Twitter app, for example, in 15 minutes, or in his lightning talk, right? So GraphQL and the service providers for GraphQL are so developed that you can literally get up and running very quickly, and this shows how easy it is, and this ease shows further how it can boost IoT adoption and solve all those problems that are plaguing the world. So you can go to my Medium page for more resources about that. I give very detailed, I write very detailed blogs about how you could do that. So taking all of this, all of this information, a lot of information. I spoke about a lot of stuff, and due to time restrictions, I couldn't go detailed into it. And I would love to talk to anybody who wants more detailed information. But taking all of this, what we see is that serverless is solving problems that once plagued the application of tech solutions, and GraphQL is accelerating that process. All right. And with that note, I would like to say thank you for having me. And if there are any other questions, we don't have that much time, but we can discuss it later. Thank you. All right. We have like 30 seconds for questions. If we can do 30 seconds of questions, that's great. Otherwise, later.
Hi, Matt. So I've run AppSync and Lambda before, and the
Pardon?
authorization is heinous.
Pardon?
I've run,
Oh,
sorry, I've run AppSync and Serverless before,
yeah.
and the whole authorization around AppSync is pretty chaotic. So how do you manage that when you deploy it on site? Do you use Cognito or do you run something external?
Well, I've also used AppSync, and in reality, I must agree with you that authentication is quite chaotic, and I think that the best way to do this would be Cognito, which again in itself is not the best solution. It's something that we have to. It's something that I know for a fact that cloud vendors are looking at. From some of the conversations I've had, this is something that also third-party tools are looking at, right? How can we enhance, especially with AppSync, how can we enhance authentication with AppSync? Another thing, thing with AppSync that I couldn't mention in the time was that sometimes not only AppSync but most GraphQL, most GraphQL applications, we don't think about the data store and authentication, and especially with the data store, you need to think about is your data store responding fast enough? And with your authentication, you need to think about, is it secure enough? Is it viable enough? And so these are some of the problems that we have. And I truly see that the industry is trying to improve these problems. And I must admit that it's a bit chaotic now, but I truly believe that maybe in the near future, we'll have better data store that provide more efficient response times and better authentication and overall services to really help us adopt GraphQL in a serverless environment. And these are the problems of joining serverless and GraphQL together, right? The tools out there just aren't, meeting the expectations of the users, of the developers, right? So I know that it's a very diplomatic answer. It doesn't really answer your question that much, but I admit that there are some problems over there. All right. Are there any more questions? If not, then there you go. Thank you so much.